In this paper titled GreenMind, a next-generation Vietnamese large language model for structured and logical reasoning, the authors, Lưu Khai Tung and Hoang Quoc Viet from GreenNode.ai, along with Vo Trong Tu from the John von Neumann Institute, introduce a new model designed to enhance reasoning capabilities for the Vietnamese language. The model, called GreenMind Medium 14BR11, builds on the chain of thought approach, which is a method that helps large language models break down complex tasks by generating intermediate reasoning steps before arriving at a final answer. Chain of thought, or COT, is particularly useful for tasks that require multi-step logical thinking, such as question answering or multiple choice problems. Traditionally, language models might just predict the next token based on previous ones, which can lead to inaccuracies because they don't always capture the full context. By encouraging the model to articulate a sequence of reasoning steps, COT allows for more accurate and thoughtful responses. The authors fine-tuned their model using a strategy based on Group Relative Policy Optimization, or GRPO, which is a reinforcement learning technique. This method improves the model's reasoning effectiveness while also reducing computational costs compared to other approaches like proximal policy optimization. However, they identified two main limitations in GRPO. First, language mixing, where the model might inadvertently include characters or influences from dominant languages like English or Chinese due to biases in the base model's training data. And second, the potential for the generated reasoning content to distort facts or deviate from the original query. To address these issues, the team creates a high-quality Vietnamese dataset specifically for reasoning tasks. They synthesize sequences of reasoning steps and then applied two custom reward functions during training. The first reward function focuses on language mixing. It explicitly detects and penalizes the presence of non-Vietnamese characters by using a banned letter dictionary. This ensures that the generated text remains linguistically consistent and primarily in Vietnamese. The second reward function targets the quality and factual correctness of the reasoning content. Here, they employ sentence transformer-based models, which are advanced tools for measuring semantic similarity. This function compares the generated reasoning steps to the original query and the labeled data in their dataset, rewarding outputs that maintain high factual accuracy and avoid distortions. By integrating these reward functions, the model learns to produce responses that are not only logically sound but also reliable and aligned with the input. In their experiments, the authors evaluate GreenMind on a Vietnamese dataset from the VLSP 2023 challenge. The results show that their model outperforms previous works in terms of accuracy and linguistic consistency. For instance, it handles tasks like question answering more effectively by generating coherent chains of thought that lead to correct answers. They also extend their evaluation to a multilingual multiple-choice dataset called C-Exam, which includes languages beyond Vietnamese. Here, GreenMind demonstrates its effectiveness in reasoning compared to simpler methods like few-shot prompting, where the model is given only a few examples to guide its responses. This broader testing highlights how the GRPO-based fine-tuning and the custom reward functions make the model adaptable and robust across different linguistic contexts. The paper emphasizes the rapid advancements in large language models and their impact on handling complex tasks. It notes that while many open-source models excel in natural language understanding, they often fall short in reasoning without structured approaches like COT. By incorporating reinforcement learning techniques such as RLHF and PPO, the authors build on existing methods to refine their models' outputs, ensuring they align with human-like judgment. GreenMind is positioned as a model tailored for the Vietnamese community, addressing specific challenges like language bias. The authors mention that their base model was trained on datasets with potential biases, so they took extra steps to mitigate this during fine-tuning. They also highlight the computational efficiency of GRPO, which makes it feasible to train and deploy such a model without excessive resources. In terms of contributions, the paper proposes new algorithms for handling language bias and controlling reasoning content quality. They utilize their Vietnamese reasoning dataset to train the model effectively and release GreenMind Medium 14BR1 as an open resource, available on Hugging Face. This model, with its 14 billion parameters, represents a medium-sized yet powerful tool for structured reasoning in Vietnamese. Overall, The work underscores the importance of adapting large language models to specific languages and tasks, showing how targeted fine-tuning can lead to significant improvements in performance and reliability. The experimental evidence from both Vietnamese and multilingual datasets supports the claim that GreenMind enhances logical reasoning while maintaining linguistic integrity, paving the way for more advanced applications in education, question answering, and beyond.